This is lesson 28, Graphing Linear Inequalities. So first a little review, how to graph inequalities with one variable. So we've got all real numbers are less than or equal to 6. We see the equal sign, so we do a closed circle, and less than goes to the left. All real numbers greater than -4 doesn't have the equal sign, so we go an open circle, and greater than goes to the right. We read this from left to right, so going to the left, we say all real numbers are greater than or equal to -2. So closed circle, and greater than goes to the right. And then coming back to the right, and less than or equal to 8 has the equal sign, so we close circle, and less than goes to the left. All real numbers less than 7, open circle at 7, and less than goes to the left. So we're going to play off of that to do today's lesson. And today's lesson is graphing linear inequalities in two variables. So you need to write this down. So take a second, hit pause, copy this down. And we can see on our top two, it says we're going to do a solid line. Why we're doing a solid line, we've got our equal symbol with us. So just like we just did a closed circle, we're going to represent that we have the equal sign, meaning that any points on that line are a solution because of the equal symbol. So we show that by making a solid line. These bottom two don't have the equal symbol, so that's why we say dashed line. Points along that line aren't solutions because it doesn't have the equal symbol. So we represent that with a dashed line. In slope-intercept form, when we're eating the y, when it's open to the y, and it's open to the y, the second and third one, we're going to shade on top, and I'll explain what that means in a second. And when it's not eating the y, when it's eating the rest of the equation, like the first one and the third one, we're going to shade on bottom. And I'll explain that here in a second. So, our first example is the ordered pair a solution to the inequality. So what we're going to do is ordered pairs are written x and y. So we're going to substitute in our values of x and y for each point and see if they make the equation true. So our first one, we'd substitute in a 2 for y and a 3 for x, and we'd finish this, so we'd say 3 times 3 is 9, 9 minus 5 is 4, and is 2 less than or equal to 4? Yes, that's true. So yes, 3, 2 is a solution to this equation. Our next one, we'll see if 2, 3 is a solution. So now we're going to substitute in a 3 for y and a 2 for x, so 3 times 2 minus 5, and 3 times 2 is 6, and 6 minus 5 is 1. Is 3 less than or equal to 1? So that's a no. So 2, 3 is not a solution to this inequality. So you guys try this one. Take a second, hit pause, try and do it. We'll substitute in a 7. 5 times 5 minus 7 is 7 greater than 25 minus 7 is 7 greater than 18. So this is no. 5, 7 is not a solution. Try our next one. We'll substitute in a 9 for y. So 9 greater than 5 times 3 is our x value, minus 7. 5 times 3 is 15. 15 minus 7 is 8. Is 9 greater than 8? And so yes, 3, 9 would be a solution. And that's exactly how we're going to do this on our homework. Our next example, graphing linear inequalities. So to graph this, we want to check, we want to look for this symbol tells us a couple things. First, the symbol tells us we don't have the equal sign, so we're going to write a dashed line. And we're not eating the y, so we're going to shade on bottom. So bottom shade. And I'll explain that here in 2 seconds. So now let's graph this with a dashed line. So our y-intercept is at -3, and our slope is 2/3. So we're going to go up 2, over 3 and put a point, up 2 and over 3 and put a point, up 2 and over 3 and put a point. We can go down 2 and left 3 and put a point, down 2 and left 3 and put a point. And now we'll show that all these points are not solutions because we're using a dashed line, because it doesn't have the equal sign. And so now, what are solutions? Solutions are going to be on the bottom of this line. So how we show that solutions are on the bottom of this line is we shade, and you don't got to go crazy with your shading, but we just shade the bottom of the line. That means that any point down below this line will be a solution to this equation, and any point above the line won't be a solution. So let's prove this to you. Let's pick out a point. This point is 4, 3. And when we do exactly what we did in our first example, when I substitute in a 3 for y and a 4 for x, let me do a little different one. Let's do 3, 4. Let's do 3, 4. 3, 4. So we're going to substitute in a 4 for y and a 3 for x and see what we get. Well, my 3's are going to simplify, so I'm going to get 4 is less than 2 minus 3, and 2 minus 3 is -1. So 4 is less than -1. Is that true? No, that's not true. I put a line through that. That means no. So that just proved that 3, 4 isn't a solution. Now we can do the same thing, and we'll pick a point over here. Let's pick out how about 3, -4? 3, -4. And this will work because it's on our shaded side. So we'll plug in a -4 for y times 2/3 times 3 minus 3, and 2/3, so -4 is less than, the 3's will simplify out, they become 1, so we have 2 minus 3, and 2 minus 3 is -1 again. So is -4 less than -1? And that's yes, that's true. -4 is less than -1. So that works. And that goes along with doing test points, that we can pick out any test point. If we're not in slope-intercept form, then the top and bottom of our line, we can't use that top and bottom of our line. So if we're in standard form, we'd need to pick out a test point, and I'll show you that here in a second. So you guys try this one. Take a second and do it. The first thing we ought to do, we see the equal sign, so we know we're going to use a solid line. And we're not eating the y, so we're going to shade on the bottom. So we look at this and we say we've got a y-intercept at 7. We've got a slope of -4/5. That means down 4 over 5. We can go again down 4 and over 5. Draw our line. Solid line. And now how do we determine top and bottom? Think about rain falling. If rain is falling, rain's always going to hit the top. So this would be our top, and this would be our bottom. And we're going to shade the bottom of this one, so we'd shade over here. So here's what we've got. If I've got a positive slope lines go up as we move from left to right. I've got a top and a bottom. Rain falling down would hit the top. It's always going to hit the top. If I have a negative slope line, my top and my bottom. If we had a vertical line, then we're talking about greater than and less than, so my top will be my greater than sign and my bottom will be the less than side. And if we have a zero slope line, then this one's the easiest, our top and our bottom. Our homework today is homework 28.